is an ETL tool. So for learning this tool, you need to know at least basic of SQL queries. So this becomes a prerequisite for this training, and it is 25-hour session. So we'll be covering practicals for performing development of interfaces, ETL jobs, plus writing procedures using KMs, and there are many more features that we have in this tool, which is make this tool better than other ETL tools. So I'll explain all. So first session, today's session, it's an introduction session. So what is the agenda for this session? Here you have. Hello, still it's not clear? Okay, in between, if it happens, let me know. I'll stop for that time and we'll continue. Okay. Okay, so this is agenda. First, we'll discuss what is Oracle Data Integrator and why do we require an ETL tool, Oracle Data Integrator? Because in market there are many ETL tool available. So why Oracle Data Integrator? I'll explain the overview of ODI 11G architecture plus the component of ODI 11G. What are the different components that we use while performing an ETL task in an ODI, and a little bit about some more component like ODI agent and repository. So you know this Oracle Data Integrator, it's a tool that is not developed by Oracle, or you can say not innovated by Oracle. It's a tool that is designed and developed by a company called Synopsys, which is a France-based company, and in year 2006-7, Oracle acquired this tool. Previously, this tool called as Synopsys Data Integrator. So after acquiring it, Oracle given a new name to it as Oracle Data Integrator. In short, we called it as ODI. So this is little history behind it, and now you know this tool is gonna be coming as a combination of Oracle Warehouse Builder plus ODI as a Oracle Enterprise Edition in future. So in future, Oracle gonna merge Oracle Warehouse Builder into ODI. So right now we have this latest version as 11G 1.1.11.1.6. So let's start. Let me tell you, there are many tools in market as an ETL tool. You guys know, like Informatica, you have Data Stage, you have Attunity. There are many. So why Oracle Data Integrator? Oracle Data Integrator has a different architecture, which is known as ELT architecture. First, let me tell you about little about the ETL. ETL stand for extract, transform, and load. These are the three synonyms of it. So extracting means extracting records from relational database, then performing transformation on it, and then at the end loading it to target. So tool like Informatica, data stage, follows the ETL architecture, where they extract the record, load it to a transformation hub server, and perform transformation over there on the data, and then load it to target. So when we talk about ETL, let me write a small diagram over here, which will help you to understand why we required to have this ETL here. So this will be understandable to you. So for example, I have a departmental store chain. For that, whatever sales happening over there, I am inserting to a database. Okay. There are three different locations from where my day-to-day sales is loading to my relational database. So this is my relational database. So this is RDBMS. So you know that a relational database management system where we are inserting record has a different architecture. So for reporting, basically why we have this ETL to move the record from relational database management system to your data warehouse. A data warehouse where you'll have a different format of data. So there are tables will be in schemas format, dimension and fact, which we use for reporting purpose. So this is my data warehouse. And ETL stands over here, which moves the record from different RDBMSs to data warehouse, and that data warehouse will use for reporting. So there are many reporting tools that use this data warehouse for fetching record for creation of reports like Hyperion, you know. There is Cognos, Oracle BI. So there are many reporting tools which use this data warehouse. So we'll concentrate on this part, ETL. What will perform over in this part? Okay. So there are many ETL tools like Informatica. You have data stage, Oracle Data Integrator, and many more are there. So the task of this tool is to fetch records from different systems and load it to data warehouse. So different system means it can be a RDBMS, it can be a flat file, it can be a ERP or any application tool which can contain the record in tabular format. So this is a complete architecture for BI, you can say. Now, why we required to have Oracle Data Integrator? So as I told you, it's an having ELT architecture which provides high performance. Why high performance? Now you can see this is the ETL, the conventional integration process. So the conventional ETL architecture where we extract the record and then transform it. We transform and then load it to target machine. So here I have my source and this my target. So right now I'm talking about ETL. So in ETL, like Informatica, what we'll do, we'll extract the data and load it to a transformation hub and server where we perform transformation. Now what is transformation? So for example, transformation of record means, like for example, I have a table employee and I have record there as EMP ID, EMP code, EMP address, okay, EMP email. So like that I have columns. Now my transformation query requirement and business rules we apply basically while transforming record. Like for example, I need the employee whose location is New York. I need employee with the ID starting from 101. Okay, so there are different transformation rules we apply. I want to have in my target I have column EMP first name and EMP last name. So in source I have only column EMP name. So what I need to do? I need to apply a transformation to get the first name and last name from the single column. Okay, like I have name over there as so I need to have in first name I need to have Gaurav and last name I need to have Talkar. This I need to have. So for that I need to perform some functions on it, or database SQL function. So getting it substring, and there are many. So these are the kind of transformations we perform on the record before loading it to target. So that we perform here in this machine, and then we'll load it to target tables. So this is ETL. But what happens in Oracle Data Integrator? Okay, so Oracle Data Integrator here. we directly fetch the record, extract it, and then load it to target. Okay, and at the target only we perform transformation on the record. So, and this transformation for the transforming record, ODI does not require to have a specific server or hub. So we don't require to move record somewhere else first and then target. We directly move the record to target. At the target we create staging area. Okay, we create temporary staging area where we move the record and then perform transformation using the capabilities of that tool of SQL and then load it to actual target tables. Okay, so it's like that. So we'll move record from, this is my source. Let's assume this is SQL server. I have one more source, Oracle. So some tables are coming and some tables are coming from SQL. So this is my target, which is Sybase. Okay, or DB2, whatever you can assume will have as a target. Now my task is to move the records tables from some tables I have here, some tables I have to move record to my target here. Okay, in between. So ODI, what it does, it create staging on your target. Okay, if your target is capable of running SQL queries, it creates staging there and it directly loads the record to this place, the staging, and then perform transformation on it and then move. So it's like this. Let me remove this. On the target itself, it creates a small staging area. Okay, so if this is my target, this is my staging. And this is my target. So on target, it's actual target you can write. So it moves record from, it performs transformation over here on staging and then move it to actual target tables. Like this. So it will be faster than other ETL tools. Now, so this is better than Informatica or other ETL tool which follow the ETL architecture. In ELT, we'll extract from source, load it to target and then perform the transformation on staging there itself. So this is one of the feature which makes ODI deliver high performance. Next, active integration which enable real-time data warehousing and operational data hubs. So this active integration means whatever we performing here, that is not required to move to the production or development. Here you have the ELT. This is ELT. For ODI, this is new, that is called as new generation ETL architecture, and this is ETL. Okay, so automatically when we need not to move record some other machine, it will become faster than other tools. So bulk data movement is faster here. Okay, so where we are? Active integration. So active integration means here we continuously can change the environment based on our requirement. As you know, in actual scenarios, we work in different environment: development, testing, and production. So usually in other tools, what happened? First, in development environment, we'll first develop all the objects, then migrate them to testing, then after testing we'll move it to production. But here there is one different concept which is called as physical and logical schemas. So we'll develop, then execute in development environment. We have connection with development plus production, and then later we while moving it to actual production, we'll execute in production environment. That I'll explain. So after getting the architecture, you'll get that. So that makes it active integration. Next you have knowledge module, which is providing a flexibility and extensibility for this tool. So this is a new term, knowledge module. What is knowledge module? In Oracle Data Integrator, we have a code template which is called as knowledge module. This knowledge module is code template which contain the code for performing specific task. So for example, if I want to move record from my source is file, okay, and my target staging is Oracle. So for this I have a knowledge module which known as LKM file to SQL, and this knowledge module contains the code, SQL code or ODI reference code, which performs the movement of record from file to Oracle. So we need not to write any SQL. This code template, just we need to select the correct code template according our source and target, and that code template, which is known as a knowledge module, will perform the task. So this is more better than other tools. So for different technologies, different source, different target, we have different KMs in ODI, which makes it flexible, and that KM code we can modify based on our requirement. Next, ODI combines three styles of data integration: data-based, event-based, and service-based. So based on the data, we can perform integration. Based on event and based on services, we can perform the integration task here. And it implement times here get shortened because of the declarative design approach of this tool. So these are some of the factors which will makes it to use other than other ETL tools. Now let's talk about the architecture. Architecture in ODI architecture, it has the basic component as a repository. What is repository in ODI? Repository. You know, there are two types of repository in ODI: master repository and work repository. So These repository is used, basically we configure these repository in RDBMS. Any RDBMS like Oracle, we can configure it in Oracle, or we can configure it in Sybase or SQL Server or IBM DB2, wherever we want to configure. Basically, when we configure it, ODI creates list of tables there for saving the projects, whatever we are creating inside Oracle Data Integrator Designer, that needs to save somewhere. So list of tables detail, columns, constraint, models, topology, the connection detail to this, so that need to be saved somewhere in the database. So ODI saves inside a repository that we configure into an RDBMS. So that is main component of ODI repository, which contains all the development we performed in ODI that's stored somewhere. So it's stored inside a repository. And these repository connects to ODI Studio. So in ODI we can have different disparate source and targets. Let me show you. I'll just open the ODI Studio. And let it open. Okay, so this is my GUI for the Oracle Data Integrator. Let me connect to it. So there are 4 different components here: designer, topology, security, and operator. I'll explain you about all of them. First, topology. So this topology shows you the list of technology that ODI use as a source, as a target. So here you can see these are the number of technology that ODI supports, and if there is some technology which is not in the list, you can add it. You can add it to this list for using as a source or as a target. So it has vast list of source and targets which you can use as a source and target in ODI. So here we basically topology we use for defining the connection. So different, we can use Oracle, SQL Server, Microsoft SQL Server, IBM DB2, SAP, Oracle BI, you have XML, Microsoft Excel, Microsoft Access as a database, you can use flat files, Sybase, Informex. There are many more source and targets that you can use. So at the top of it you have a ODI Studio, which contain 4 different tabs: designer, operator, topology, and security, which we'll gonna use for performing the ETL development. And this Oracle Data Integrator can be deployed on application server like WebLogic. So we can deploy it and then you can access it through a web browser on any remote machine. You need not to install it everywhere. You can install it at one machine sitting on the application server WebLogic, and you can deploy it as a component ODI console, and that you can access it through URL through web browser in any remote machine. So whatever you are developing, you can access it there. You cannot perform development, but for sharing object developed there, you can use it. You can execute the objects and you can access them for verification. Yes, we can install it without WebLogic also. So it depends on your choice. If you want to access in different machines without an installation, you can deploy it on WebLogic with, or else directly you can install and distributed system as for example you said, you can do it that way. You just need to access the same repository for that. So that way you can install. So now how ODI connects. Let me just give you more features about ODI first, and then I'll tell you. There is two repository, master repository and work repository, and one more is there which is called as execution repository, which is used in production. There is no save repository over here. Master and work and execution, three types of repository we have, and that execution repository is kind of work repository only. So master, the work repository connects to master repository. So in one master repository we can have multiple work repositories. So I'll explain the concept behind the repository later. So let's talk about some more features, like it has faster and simpler development and maintenance. As you can see, faster, I already told you how it is faster. Simpler development, because here when we use this tool, its UI is pretty easy to use. You just need to drag and drop objects, map the columns, specify the KMs for moving source to target, specify options, and execute. That much simple it is. And later you can maintain also easily. You have a data quality firewall here. There is one KM called CKM. I'll explain you about, there are 6 type of KM. I'll tell you all of them. So there is one KM called CKM, which is used for data quality firewall. So for example, when we move record from source to target, this is my source and this is my target. Here you can create a firewall which filters the inconsistent records which is coming from source. So how it filters? We basically write constant. Okay, so there are different types of constant, like primary key constant. You have check constant. You have not null column, unique key constant. Okay, some mandatory column. And so all these conditions what you have defined on target, while moving the record from source, ODI checks here itself while flowing the record from source to target. So in the flow it checks all the constant. Whatever rows are satisfying these constant, only those rows will load to target. Other will not load to target. So this firewall stops inconsistent records to get populated into the target information system. Next you have better execution performance. So execution performance is better over here. it is faster and better. We can migrate the object here in an XML, and we can move it by importing and exporting. So whatever object we develop in ODI, that can be migrated by importing them in an XML file, which is called as scenarios over here. Next you have simpler and more efficient architecture. So architecture I already explained you is more simpler. The ELT architecture, extract it, load it to target staging, perform transform, and then move it to actual target. Platform independence means it can be installed on any machine. It can install on Solaris, AIX, Linux, Unix, Windows. People used to ask me about Apple iMac also, but still I have to find out, is it possible on Apple iMac or not. So, but jokes apart, it is platform independent. So you can install it on any machines. Data connectivity. So data connectivity, I already told you that it has the vast data connectivity. It can connect to any database tool plus application tool and flat files, XML, Excel, any. One more feature, cost saving. So automatically, if you don't have the transformation hub or server required here, if you don't require that hub like other tools, automatically it's get cheaper, and the license of this tool is less cheaper than other. Sorry, less expensive than others. So this way you can say this is more cost saving. Now components. So these are the component: designer, navigator, we call it as designer navigator, operator navigator, topology navigator, security navigator, agent, console, and repository. So one by one we'll take a look on it. Basically these all components connects to a repository, all, and whatever development we are performing there in these navigators store inside the repository. That means inside a database system in a table. So first is designer navigator. The designer navigator is the navigator that as a developer you use more. So you can define projects over there, you can define models, all ETL tasks basically will perform over there only. So for example, if I show you designer, this is my designer navigator. I have one project created over there, and this is model tab where I have model. So this is one of my model for file. Here I am accessing a text file which I can see record from that file. This is record coming from a file. You can see over here in a grid. So these records are not saving somewhere in the repository. Whenever I am right clicking and selecting data, ODI is executing a select query on that text file and fetching records. So these records are not storing, only the model, the table name, which you can see here, these tables. Inside that table, if you have columns, that columns all stored inside the repository, plus constant. If you have defined constant like primary key constant, foreign key constant, that is storing inside the repository. Okay. The data is not storing inside the repository. This is data is get accessed when we click on data. It's just writing a select query, you can see, on that table and fetching record from the actual table. So you can see records over here. Yes, it's stored in DB schema. It's a database schema. Yeah, metadata, you can say only metadata you store inside the repository. So metadata means table structure, constraint, column name, store inside the repository in a database schema. So what else we save there? We save projects. If we have created any project, any ETL job, basically ETL jobs called as interface over here in the ODI. So like for example, I have one interface. I'll show you how it look like. So here you can see. So this is pretty simple. Here you can see this part of my screen is source, and this is target. Source table, target table. I have to drag and drop table from here in from the model tab. Like I dragged it and dropped it like this. Okay, and then column by column I can map them. So what column I have to map to which column, I can map, like drag it and drop it on that column. Like that I can map. If I need to write some transformation, I can write the transformation, like I have written substring over here. We can see a substring. I'll get the list of functions supported by that technology, which I can write. So I need to drag and drop source target. I have to map them. Later I have to, there is one flow tab where I have to specify the KM. So I'm using one IKM SQL increment, which is moving record from basically my source and target on same database. That's why you are having this flow. If I change the staging somewhere else, flow also get changed. You can see the flow. Record how it's moving. This is my source. I'm moving it to staging, and then from staging to target. So we can, it's flexible. Staging we can create anywhere, on the source, on the target, or if both source target does not support SQL, we can create it on a third database. So that much flexibility you have in ODI. So in some cases, like for example, I'm moving record to a file from RDBMS to file. So my file does not support SQL queries. So performing transformation, I need to have SQL to execute. So for that, we create the staging on source, because my source is Oracle, so it supports SQL. So I can create staging on source and then move it to target file. So if in case my source also not an DBMS, like for example, I'm using Hyperion as base, which is an application tool, does not support SQL queries. So and my target is file. So in both our source and target are not SQL supported. So I need to create staging somewhere else. So I can use any other technology as a staging. Yes, or this Oracle Data Integrator can connect to Hyperion As-Base, Hyperion Planning, Hyperion Financial Management, and it can use these tools as a source or as a target. No issue. Both is possible. Okay. So this is general scenario. So this is one of my interface, ETL job you can say, which moves data from this Go branch dimension table to one of my target table. See, ODI is not an database. It's not so it cannot be a source. It's a tool standing in between source and target. So source can be a Oracle database or a file for your target Hyperion. Yes, it's correct. You can move it like that. Oracle database to ODI and then planning. So ODI will perform this task. So this is the one of my ETL job. So this is designer where I have all these ETL jobs. So not only there is one more thing called this ETL job I can combine in a one package. Package basically we use for creating a bunch of job, because like for example I can have one target at a time. We can have multiple source tables where we can perform joins and load record to one target table. So if I want to load multiple target tables, I need to create multiple interfaces, and then those interfaces have to execute in a single job. So what I need to do, I need to create a package. Basically this execute on means we have to, this transformation we have to execute somewhere, the mapping which we are performing like this trim. So it can be executed on source, it can be executed on staging, or it can be executed on target. So depending on, source and target technology, like for example if my source is a file, I cannot trim it on source. I cannot execute this trim function on source because my file does not support SQL. So this trim function supported by a database. So that I need to have select this staging. So that will execute on staging. Okay, and then later it, after performing trim, it will move to target. So till staging, or data will come as it is. Like territory, if America, something like for example, I have a file as a source. Okay, I have 1000 record over there, and my target is Oracle, and I have to perform filter. Filter means, like for example, I have a table customer, and my requirement is that I need only customer whose age is greater than 20. Okay, so what I'll do, I'll create file dot age, its column name greater than 20. It's my query. Simple. I'll write a filter. So this filter need to execute on SQL only. So I'll move all these 1000 record to staging, and on the staging where it support SQL, I'll filter the record. So after filtering, I'll get from 1000 200 record only, because I have 200 customer with age 20. So it will, from staging it will load 200 record to target table. Like that it will happen. So till staging you'll have 1000 record, there it will filter it and load it to target, like that. So execute location basically depends on your source and target technology. See here we have packages. These packages we can schedule to execute. We can generate scenario for them and then we can schedule. So I already have somewhere schedule some package. See scheduling here you have. So this scheduling you can perform, and whenever you want you can define the scheduling time, and accordingly it will execute. So there are different execution scheduling time. You can execute simply hourly, daily, weekly, monthly, yearly, or you can specify a time which you can execute. Okay, so for that we have this package. See, basically that staging is temporary. Temporary means it will, ODI will delete it. After performing the transformation, it will delete it. So no need to have double size. But if, like for example, if it is millions of records are coming, it need to be having that size. It can have temporarily handle that record. basically ODI install, you can install it anywhere. No need to install on the same machine where you have target DB or source DB. It can be on third machine and it can connect to that DB. So that's, I'm coming to that. Uh, so this is designer. Basically, you can read down this. Designer Navigator is the graphical user interface for defining metadata and rules for transformation and data quality. So it uses this information to generate scenarios for production, and designer is where all the project development take place. So Designer Navigator is the core module for developers and metadata administrator. So it handles models and projects, where model basically description of the data and application structure, and project where the development of various ODI objects will perform. So this is designers. Next you have Operator Navigator. One more navigator of ODI. Why we use this Operator Navigator? The Operator Navigator is used to manage and monitor ODI in production. It is designed for production operators and displays the execution log with error count and the number of row processed. So you get the execution statistic in Operator Navigator. So at the design time, developer use Operator Navigator for debugging purpose. So for example, I'll show you. If I have execute any of the interface like this, I'll execute. So after executing, I need to check whether it executed successfully or not. If it is executed successfully, how many number of row processed, how many rows loaded, if there is something rejection of record based on the data quality filter, how many record filtered. So that I need to check in operator. So in operator, I have list of executions. So you can see here, there are different date wise you can see. So one I executed today, and it's showing green sign, that means it has executed successfully. So you can open it and you can see the number of insert, number of update, number of delete, number of errors, number of row processed. So like that you can verify your execution. This is kind of log. And even you can see these are the KM code. Basically KM has a list of codes, commands that is listed over here. So it has created a table, then dropped it, and then flow table it is creating. Flow table basically a staging table, then truncating target table, then inserting record it to flow. So this way you can see. So like for example, insert flow into $i table. So you can see this. Here you can see the code. So what code it has executed, you can see over here. So it's inserting record to a temporary target staging table by selecting it from a source table. So it's selecting a record from source table, implementing the rules, and inserting into a temporary table. See, basically there is one more thing called simulation. Simulation we use to get the code only. Instead of directly executing on database and loading record, you can simulate it like a simulator. You'll get all the code which gonna execute on staging or target. What will be the code? Unnecessary, you need not to execute every time to get this code. What are the case statement and all? You'll get it over here. Okay, so for performing updation and all, you'll get the simulation. So this you have as a steps over here. So you'll get this logs over here uh, based on today's execution, yesterday's, based on physical agent, and there are different agents. Based on that, you'll get this log session wise, status wise, how many failed, how many executed successfully, okay, how many having warnings, you'll get it. If anyone having some execution failure, so you can open that failure step and you can check what is the issue behind it. So here you can see the issue, value too large for the column, actual size is 40, maximum is 20. So that way you can find out the issue over here. So this you have in operator. What next? Next we have Topology Navigator. So the Topology Navigator is used for connecting to the source and target technology, the information system. So like for example, my database is in some other location in Boston, my source database. So I need to connect to it. So for defining that connection, we use Topology Navigator. We define there the JDBC driver, the name of the server, and the URL to connect to it, and IP address. So all this will define, and that server will be connected to ODI. So here, when you open it, topology, like for example, let's talk about Oracle. So I already have defined one data server. So you can see if for example, I have a data server somewhere, Oracle database instance. On Windows machine. Somewhere in Boston. So I need to connect to it ODI. So for connecting it, this complete server I need to define. So that will define in ODI as data server. Okay, and inside these server you'll have multiple database schemas. Okay, like sales, you have account, order. So there are multiple schemas. So those schemas will define as physical schema in ODI. So first we'll define data server, which will connect to complete server, and inside that will connect to schema, specific schemas, because schemas contain the tables. So for that we define physical schemas like I did. This is my data server, a development data server. Inside that I have two schemas defined, two different database schemas. So one is sales, which contain the tables, some tables, and this one other one which contains some other tables. So on the data server I'll define the JDBC URL to connect for that technology. Okay. So this way you define the server and physical schemas. So when you define physical schema, if you are connected to server correctly, you'll get this drop down list populated with the list of schemas inside that database. Okay. This way. So I can select the one which I want to use as a source or as a target. So after defining it here, you can use it as a source or as a target. It's your choice. But we have to define the connections here. So this is your Topology Navigator. So the Topology Navigator manages the physical and logical architecture of the infrastructure, like servers, schemas, and agent, which are registered inside the Topology Navigator, and all stored inside the master repository. So all detail, whatever connection we are defining, that's stored inside the repository. See, when we define the physical schema, there are two schema we have to define: work schema and schema. So schema basically the place where actual tables is present, and work schema which ODI uses while using that schema as a target. So in flow, if I'm using this as a target, ODI need to create staging. So for this we use for staging. So ODI create this part as a staging. So you can define anyone else, or you can create a specific database schema for staging only. So while using this sales as a target, ODI create the temporary table in some other schema, which you define here in work. Okay, so for this we have this work schema. Okay, so this topology basically defining for you can define the information system, and this can be accessed by other module of ODI. Last we have security navigator. The security navigator is basically kind of administrator navigator, where we define we use it for as a defining users, providing authentication privileges, assigning rights to them. So for that we have this security navigator. It basically whatever user if working on ODI, so we have to assign rights to them, so that every user cannot access every project or every navigator. Because if I am a developer, I need to have access on designer. As a metadata administrator, if my friend is metadata administrator, he need to have access on topology. So through security navigator we define all these access and rights. Here you have security. So there you have users, profiles, and objects. So profile, basically pre-built profiles are there which we assign to user. Like designer, you have designer. If I want to assign rights to one user as a designer, I can drag and drop. Repository explorer, security admin. So there are many, and these objects basically related to a single action. Like for example, I have technology here. So I want to assign this action to a user so that he can access this technology and it can perform these tasks to the technology, like delete, duplicate, import. So we'll assign it to a user. Basically these tables are staging tables with prefix. You can change them. So error table, if ODI creates error table, it creates with $E. Loading table with $C. We can change these prefix. So like for example, my target table name is employee. So ODI will create staging loading table with name $C underscore employee. Error table with $E underscore employee. Integration table with $I underscore employee, like that. So for that we have this. So this is security navigator. So there are many more things like agent we have. What is agent? So agent is one more ODI component which is kind of listener, a Java listener, which we use for initiating the processes. So whatever development we have performed, whatever development we are performing over there, that development need to execute. So agent is kind of Java listener which will help us to perform the scheduling task. So like for example, I created one object interface to move record from source to target. Now I want to execute around 12 AM IST and I cannot be there. So I schedule it and assign to an agent and start the agent services, and then that agent will look after it. Or at the time, specified time, it will execute that object. So for that we have this agent. So I'll explain you more about this agent. So there are many things we have, repository connection and all. So that will look after in upcoming session, next session. So you guys will have lots of queries. So let me take up one by one. So you can, I'm